Hi students, I am Sandhya, Assistant Professor, Department of Mathematics in SNS College of Technology. Today we are going to see the matrix form for a quadratic form. So, if it is a equation, one equation is given, we have to convert the equation as matrix. First, we are going to see what is quadratic form. So, quadratic form is nothing but the homogeneous polynomial of second degree in any number of variables. So, the homogeneous of second degree in any number of variables. What is homogeneous? Homogeneous is nothing but the power of all variables is second order. So, here see, in this x1 power is 2. In this x2 the power is 2 and x3 is the power 2. Here adding x1 and x2, here also the power is 2. Here also the power is 2, here also the power is 2. So, the homogeneous of polynomial of second degree in any number of, this is the variable, it is the quadratic form. So, in this problem is a quadratic form. So, in this quadratic form, we have to convert it as matrix form. So, how we can, this quadratic form can become the matrix form, we have to using the formula. So, here the formula is coefficient of, here we have to write x1 and x2, x3. Here also we have to write the x1, x2, x3. So, here this is the that is x1 square and this is the x2 into x2 square. First we have to fill the diagonal. So, again x3 square. So, here we mention x1 square, that is coefficient of x1 square. Here also coefficient of x2 square. Here also coefficient of x3 square. Here x1 into x2, that is coefficient of x1, x2. So, here a into b is, that is 2 into 3. The answer is 6. Similarly, b into a, 3 into 2 is also 6. So, x1 into x2 is same as x1 into that is x2 into x1. So, coefficient of that is x2 into x1. Here also x1 into x3. So, here we have to fill the coefficient of x1 into x3. Here also we have to fill the coefficient of x2 into x3. Okay. So, here we have to fill the coefficient of x3, x1. Here also coefficient of x3, x2. So, using this formula, we have to replace the quadratic form into the matrix form. So, here the given variable is x1, x2, x3. So, we have to put x1, x2, x3. Here also x1, x2, x3. Okay. First, we have to fill the diagonal. So, in this diagonal, no change. So, here we want to fill the, so x1 square, the coefficient is 2. Here the coefficient is minus 2. Next x3 square is, that is 4. Okay. So, in this diagonal, we have to write the coefficient form. Remaining elements are, we have to dividing by 2. That is divided by 2, divided by 2, divided by 2. Here also divided by 2, here also divided by 2, here also divided by 2. But in the diagonal, no need to divide 2. Okay. So, here see coefficient of x1 into x2. So, here what is x1 into x2 is 2. That is our coefficient of x1 and x2. We have to divide by 2. So, 2 divided by 2 is 1. Here a into b is b into a. So, similarly x1 into x2 we have to, that is 2. x1 into x2 is same as x2 into x1. So, here also we put 1. Okay. Then what is x1 into x3? Here see x1 into x3 is minus 6. Then we have to dividing by 2. So, that is minus 3. x1 into x3 are minus 3. Then x1 into x3 also minus 3. Then we want to put this one. So, here see x2 into x3. That is x2 into x3 is 6. So, we have to divide by 2. That is 3. Also, x3 into x2 is same. That is 3. So, this is the matrix form. So, quadratic form is given, we have to convert the matrix form. So, similarly, we have to find the write the quadratic form for the following matrix. That is is vice versa. So here the quadratic form is given, we have to find the matrix. Here we want to form, given the matrix, we have to convert that as a quadratic form. How we can convert the quadratic form? In this quadratic form is a second degree polynomial of any number variable. So here we put x1, x2, x3 or xy, z. So I am using this xy, z. Here also xy, z. So xy, z is a variable. So here first we have to write the diagonal. In this diagonal now we need to divide x. Isn't it? So we have to write x into x is x square, y into y is y square, but here 2, so positive, 2y square. Here also minus z square. Then next one is we have to write the remaining element. So x into y, that is 1. In this we have to divide by 2. Here we have to convert it as a quadratic form. How we can convert it is we have to multiply by 2. Isn't it? So we have to multiply by 2. So this is 2xy. xy or yx. It is same. Then we have to write minus xy. That is here also 1 we have to put xy. Then so we have to fill this one and this one. Okay, completed. So the remaining one is that is y into z. Here also 1. So we have to multiply 2. So that is y into z. So this is our quadratic form. Here see the quadratic form. It is a homogeneous power 2, power 2. Here also power 2. Here also adding power. So all the it is a homogeneous of polynomial of any degree. So this is the quadratic form. We have to find the quadratic form for the matrices given. Okay. So here next our topic is reduction of quadratic form to canonical form by orthogonal transformation. So in this canonical form is canonical form. So in this canonical form is we have to y transpose d into y. Okay. So what is d? D is you already know. What is d? D is nothing but the diagonalization of the given matrix. In the diagonal, the eigenvalue is apparent. Okay. So remaining elements are 0. Okay. So but y, what is y and y transpose? So y is nothing but y1, y2, y3. Okay. So it is the, that is y1, y2, y3 is y transpose. What is y? Y is, first we have to write the that is column y1, y2, y3. So this is our y. This is our y transpose. This is our diagonal matrix. In this diagonal matrix, for example, so for example, the diagonal is d equal to, the diagonal matrix is 1, 0, 0. 0, 2, 0, 0, 0, 3 for example. Okay. So this is our diagonal matrix. In this diagonal matrix, what is our canonical form? So the canonical form is we have to multiply y transpose d into y. So y transpose is y, that is y1, y2, y3. Here the d is given matrix is 1, 0, 0, 0, 2, 0, 0, 0, 3. So here next one is the y. So here the y is y1, y2, y3. So here we want to multiply y1 square, that is y1, here also y1. So that is y1 square plus here 2y2 square plus 3y3 square. So this is our canonical form. Canonical form is sum